Okay, so this is lesson 15. 15 is all about ICE, or initial change equilibrium calculations. So equilibrium is when we have reaction going both forward and backwards. And a lot of times what we want to know is, hey, if I know the initial concentrations of all, what are my equilibrium concentrations? And we're going to do a problem on this in a little bit, but the key is we need to know these changes. So video problem 15A is all about figuring out what these relative changes are. And so what we do is we place an X for that change. Okay? So in this case, I tell you that I2 is minus X. So if I2 is minus X, what does that mean? Sorry, my setup's a little different, so I need to get used to it. Okay, so if I2 is minus X, that means that I'm decreasing I2. So that means I'm also decreasing I minus. And I'm decreasing it by the same amount, because 1 to 1. And if reactants are decreasing, that means products must be increasing. So that means plus X. What this means is that no matter what X is, X could be 5, it could be 20, it could be anything. This is minus 20, this will be plus 20, right? We can just use our stoichiometry to figure out those relative changes. All right, B, we're told that C2H2 goes up by plus X. Well, if my reactants are increasing, that means this must also increase, and that means this must decrease, right? One side must be positive, the other negative. Here it's negative and positive, here it's positive and negative, but all my reactants will be the same. All right, so this is plus X, this has to be plus 2X, because it's 1 to 2. All right, and then this one must be minus X, because it's 1 to 1, all right? Now, notice that if this is increasing, that means this is an equilibrium that's shifting towards the right. Here, if reactants are increasing, that must be an equilibrium shifting towards the left. All right, let's look at the last one. We have C3H8 plus 5O2 going to 3CO2 plus 4H2O. Notice how I didn't say which one, it doesn't matter which one you make negative. That comes from actual ICE problems, which we'll do in a little bit. But in this case, let's say I want to say it shifts towards the right. That means these will be negative, these will be positive, okay? So if this is minus X, this will be minus 5X, this will be plus 3X, and this will be plus 4X, right? I'm just using my stoichiometry. And then, if instead it shifted the other way, this would be plus X plus 5X, and then minus 3X and minus 4X. Okay? So, this is shifting towards the right, towards products. This is shifting towards the left. All right. So, relative changes is key when we do ICE problems. All right, let's go on, and let's just show this on the screen. Now we're actually going to go ahead and do an ICE problem. And I have this set up a little bit different, so hopefully it works all right. Okay, oops, wrong way. All right, so now we're going to do an ICE problem. This is video problem 15B. So we have NH3 plus H2O going to form NH4 plus OH minus. And we're given a K. And we're asked what are the equilibrium concentrations if a solution if it is initially 0.25 molar NH3. All right, so I have my page set up. I have it set up so that way I can move it around as needed, hopefully. All right, so I have NH3 plus H2O goes to form NH4 plus OH minus. We're told that K equals 1.8 times 10 to the minus 5. I always like, when I first do these, and I should have put this over to the right a little bit, is I like to write out the equation for K, okay? And that'll be the same equation for Q, except one's at equilibrium and one's at initial. So K or Q will be NH4 plus times OH minus over, I'm just going to get rid of that, NH3. Why don't I include the water? I don't include the water because it's liquid. Okay. All right. So now I have this. Let's go ahead and set up our table. So we have ICE. Okay. I'm going to leave one spot open to the right because we're going to use that later. All right. Now, the first thing you do is when you see that something is liquid or a solid, you just X that out. We're not going to use that. All right. Let's look at the problem. We have 0.25 molar NH3 initially. We have, and it doesn't say anything about NH4 plus and OH minus. So we have to assume that these are 0. Okay, so now let's go ahead and let's use our equation for Q up here. This will be 0 times 0 over 0.25. So that's going to be 0. Okay, so my Q is 0. My K is 1.8 times 10 to the minus 5. So that means I have to shift towards the right. My K is larger than my Q. Okay, so if I'm shifting towards the right, that means I'm making products. So that means products are going to increase. All right, so these are going to be positive. Notice there's ones in front of both these. They'll be plus X. This will be minus X. Okay? Everything on one side will be positive. The other side will be negative. All right? If this were, let's say, 2OH, then this would be plus 2X. But that's not the case here. All right, so now we go to equilibrium. So that'll be 0.25 minus X. This will be 0 plus X, so that's just X. This will be 0 plus X, so that's just X. All right, and now I go ahead and I plug these back in to my calculation for K. By the way, notice I'm spreading this out, trying to give myself space. I probably should have moved it over this way a little bit more, but que sera. 0.25 minus X. All right. Products over reactants. Nothing's raised to a power because I have no 2s or 3s in the coefficients. The problem we did on the other video had coefficients, so we had to square things. If we don't have to. All right, so that's what K is. So I can go ahead and I can say, all right, that'll be X squared over 0.25 minus X equals 1.8 times 10 to the minus 5. Okay. A lot of people forget that we know what K is, so we can add that in. Now we have an equation. And now I want to go ahead and I want to solve for X. All right, now there are two ways to find X. A simple way and a harder way. The harder way uses quadratic equation. That's something we'll do next lecture, okay? The simple way is to use an assumption. It turns out that this one we can do an assumption for. We can do an assumption only if X is small. How do I know that X is small? Remember, X is the difference between Q and K, okay? That's the change. Well, my Q is 0, and my K is 1.8 times 10 to the minus 5. So those are both small, okay? In the lesson, I say you can do it if both smaller than 0.01 or both larger
than 1,000. Okay. These both are smaller, so I can make that assumption. So I'm going to say I'm going to assume. And so what I do is I assume x is so small that 0.25 minus x equals 0.25. Okay. I don't assume that x squared equals 0 because this, if I do this, then I wouldn't be able to find an answer. So I can just get rid of that. I'm going to assume that. And so that means that x squared over 0.25 equals 1.8 times 10 to the minus 5. Or x squared equals 4.5 times 10 to the negative 6th. Okay. And so I do the square root of this here, and that's 2.12 times 10 to the minus 3. All right, now I go ahead and I take these x and I plug it back in. So this will be 2.12 times 10 to the minus 3. This will be 2.12 times 10 to the minus 3. And this will be 0.25 minus 2.12 times 10 to the minus 3. And that's going to get me, can you see it's still, minus 2.12. 0.248, okay, molar. All right, now I have to do two things still. I need to check my work with K, and then I need to check that assumption, okay? So let's check our work. Let's go ahead and just plug back everything into our K value. So this will be 2.12 times 10 to the minus 3 times 2.12 times 10 to the negative 3 over my NH3, which is 0.248. That's going to get me I'm going to square that, divided by 0.248. That's going to get me 1.81 times 10 to the minus 5. I start off with 1.8 times 10 to the minus 5. I ended up after the calculations with 1.81 times 10 to the negative 5. So that's good. All right, the last thing I need to do is I need to check my assumption. All right, what did I do? I assumed that 0.25 minus x equals 0.25. In reality, it was 0.248. So what I do is I go ahead and I say the percent off is the actual minus the assumption. Okay. Or actually, sorry, it's assumption minus actual. It doesn't matter because we're going to do a square root of it, or we're going to do absolute value over the true. Okay, so it's my assumption over the actual, or minus the actual over that actual. So multiply by 100%. That's going to get me 0.8%. And in class, we learned that less than 5%, we're good to go. All right. Okay, so that is a nice problem, okay? I'm sorry to say this is a fairly easy ICE problem. We will do more difficult ones. You'll get used to it, but you always have to do the same things. Let me go ahead and grab a highlighter. We start with our equation. We make sure to X out anything that's a solid or a liquid. Then we go from initial to put that into Q to find Q, figure out our change. Then we come to our relative changes. So we kind of do a snake. We plug those back in to get equilibrium concentrations in terms of X. We come up with something for K, and then we solve for X. Sometimes we use the assumption, sometimes we have to use quadratic. In the end, once we have it, we get our answers, and then we have to check our assumption and check our work. All right, so that is it for lesson 15. Let me go ahead and just show these on the screen in case my writing wasn't all that clear. So you can see here my initial, I plugged everything into the table. I plugged everything into my table. I didn't include anything for the H2O because it's a liquid. Found Q, found my change, plugged it back in, right? Then I made my assumption, right? Here you can see that assumption. I solved for X, and then finally, here are my answers. But I wasn't done because I need to go back and I actually have to check and make sure everything's right. So I check my work, I get a valid K, and I check my assumption, it's less than 5%, so I'm good. All right, so next time we're going to go on to some other ICE problems and some more topics in equilibrium. All right, talk to you later. Have a good day.